Hi everyone, this is Venal Fargos. Um, my project's name is LCA based prediction. Uh, so let's begin. Now, what is LCA? Let me just give you a brief idea about how is the process beginning. Like I follow the CRISP TM process here. So let's just start with the business understanding of my project. We all know that talent acquisition is really difficult in like nowadays. And we all know that especially in corporate America, many tech jobs have applications coming directly from international candidates. These candidates will need sponsorship if they want to work in the US locations because they are not citizens. Basically, they're not permanent residents. And we all must be aware about the H1-B visa process, right? So that's the H1-B process. It's like eventually the lottery that's there. So nowadays employers are really reluctant to hire the candidates who are international, even though they are skilled. I mean, it's fair, I think, that it's because if they are not certified in H1B, then it's going to be they eventually will have to leave the country, and then it's like a loss for the employer. So my project is based on the LCA. It's a step before H1B process. That's the labor condition application, which is certified by the Department of Labor. Once an LCA is certified, or candidates goes for the H1B lottery. So H1B is random, it's not in our hands, but LCA is something that we can handle. So that's what my project says. And it's going to describe. I'll walk you through the project, so don't worry about it. I got the data set directly from Kaggle database dataset, and this is a fresh data for 2017, year of 2017, and it's directly taken from the DOL, the Department of Labor website. It's a fresh data, it's a public data that the DOL publishes every year. The data is fairly large, it's like around more than 6,000 records, and it's 600,000 records, and we have like 53 predictors. Of course, I'm not going to take all of those because it's not going to eventually fit my model. It's like there's probably like raw data inside it. I'll walk you through the process. Let me go and based on my domain knowledge, the features that I have selected to to predict my case status. Case status again is my response variable. Either it's going to be certified or denied. So that's the LCA, certified or denied, and that case status is going to be dependent on the SOC name. SOC name is nothing but a job title that a employer has. The total number of workers that the employer is giving for that particular year. Is there an agent representing the employer? It's just like a binary categorical variable, yes or no. What's the prevailing wage? Prevailing wage is nothing but the salary of the employee. Then case submitted date, when was the case submitted? Is the employee full-time or part-time? Is a violator? What state it belongs to? And there are other different data predictors that I have considered into my model. It's practically impossible for me to find a correlation between address and like there are many features or 53 features like the address of the employee worksite, and it doesn't really make sense for me to consider in my data set and fit my models with that data. So these are the correct data sets I believe, correct predictors I believe in my data set. Now let's begin with my coding thing. What I've done is, let me. So this is my okay. So this is my case status. That is the response variable I told you. And from the original data, it has 4 stages: that's certified, denied, withdrawn, and certified withdrawn. But I'm not going to actually consider all of those because withdrawn is something that it's not like it's an employee wants to withdraw an application, so it's not really a thing that an employer can do or the Department of Labor can do. So I'm not going to consider those cases. It's just like certified and denied. These are different bar charts that I've done for different categorical variables and just the data, like how many yeses we have, how many no's we have, the full-time employees, how many full-time employees. Visa class can also be like H1B, H1B Chile, H1B Singapore. These are different H1B categories that come into picture. Now, like I told you, I'm going to subset the certified and denied levels from my response variable, and I'm just considering those two. I'm leaving those out too. So it's just certified and with certified and denied. I'm not considering certified, withdrawn and withdrawn. So I just null them off. Now the next step is extracting date, like the year and month from the dates. I don't really want to fit dates directly into my model because it's not going to give me a good accuracy. So I've extracted those years and months out of it. Now this is just like the data. If you want to see the structure of the data, it has now become 24 variables, and still we have like 4,000 records. Let's see how we can handle it. It's like a lot, I know. Okay, now comes the feature engineering process. SOC name, like I mentioned before, it's one of the most important features because it's a job title. So the Labor Department will actually see is our do we have enough candidates in the United States, or do we have enough citizens with this skill that we need international candidates. So in this case, if they have if they think that we have enough enough people with that skill, they are eventually gonna deny the application. So SOC names play out. It's like a job title. It plays a key role. There are many job title SOC names in my data. It's like more than 10,000, and to fit, and it's a categorical value. I cannot just discard it because it's an important predictor. So what I've done for it is I've actually grouped them into clusters. So wherever I find a word software, I would just give it as software analyst. Wherever I find a word engineer, I would just give it a word as an engineer. Like it can be a chemical engineer, a mechanical engineer, electrical engineer, anything. So that's how I can lower my or reduce my categories. So these are the only categories that I'm considering for my SOC name. I mean, these are all the possible categories. It's just like grouped. I'm not deleting like any, unless they are very, very small. I'm not deleting any important categories. Now the next thing is the data that I've just created a prevailing wage column, which is annually, because it had like bi-weekly, and the data wasn't just like annually. It had the salary was based on month, year, weekly. So if it's hourly, I've multiplied it by 2, so 80 month, and 12, if it's month, it's 12, week is 52. These are all the working units in a year. And then I made my prevailing wage column as uniform annually. There are certainly outliers in my data. That's like the data which is more than there's data which is like you're paid like more than $300,000 per year. Certainly, I don't want to include that data in my model, so I've just removed it. Now comes the important picture about the sampling of my data. Now, if you can see here, the certified cases are 98.989%, and denied cases are like they're literally like 1%. I do not want to have such imbalance in my data because eventually it's not going to give me a good fit model. So I've used a roads package and sampled my data. There are various ways that you can do your sampling. I've used undersampling, and I've taken my data set. I've reduced my data set to 15,000 records. So what it'll do is it will just randomly discard all the data set, all the cases from the certified stage because it's dominated, and it'll try to give me a balanced data of like now it's 73% and 26%. So now I can fit my model with that data. Now what I've done is I've built 4 models here. First one is logistic regression, then it's support vector machines, decision trees, and random forest. What I've done is every model will need a different pre-processing. Like most of it will be same, but like here and there, like dummy variables and normalization. So I've created a new training data set for each model. So I've built 4 different models. That's the logistic regression here. I've created dummy variables for it because, again, I told you it just accepts the numerical values. So I've used a dummy wars function from the caret package. It'll give me, and full rank is equals to t stands for n-1 categories because that's what we want. And I've created my model and I've calculated the accuracy. Similarly, I've calculated the model accuracy for all the other models. That's the support vector machines. I've created dummy variables for it too because it wants numerical values as well. I've normalized the data here for numerical values. Then I've created a testing and training data set, and then I've built my model again and then tested it using the predict function. It gives me an accuracy of 75-19%. The next is the, I've also done k-folds cross validation for it, which gives me like 74.55% accuracy. Decision trees is the next that I've used. That is because SVM is again a black box model. It won't really tell me what happens at each stage. So I've used decision trees so that I can, get more transparency what happens at every stage. So I've used decision trees, and it gave me a good accuracy of 74.56%. Like you can see here. And last but not the least, I've used random forest. It's like a big father of decision trees. It's gonna build a forest there, like with multiple decision trees. And if you see which is like a summarized model accuracy, logistic regressions give me 75%, support vector 75.99%, decision trees 74.56%, and random forest is 79.76%, which is pretty good, I think, for the data that we have taken, a subset of the data. But yeah, of course, we can, with fine tuning, we can definitely increase the accuracy. And last but not the least, I've also considered doing an ensembler. Ensembler, I think it's very important because just like it does. There are two types of ensemblers: one's boosting and one's bagging. And it calculates there are different ways you can do. I've calculated the majority class, that's the mode. So my response variable is going to be predicting either 1 or 0. That's 1 stands for certified and 0 stands for denied. So if you can see the logic here, if predict.spm is 1, predict.logistic regression is 1, I've just created separate variables for each model. It's going to be 1 because I've considered only 3 models here: SVM, logistic regression, and random forest. So of the 3 models, if 2 of them predict 1, it's going to be 1. Else, it's going to go and check for SVM and forest. If it's 1, it's going to be 1. If not, it's going to check for the other 2 models. If it's 1, it's going to be 1. Otherwise, it's going to be 0. And that's how I'm calculated the ensemble stack, and it's 79.19%, which is pretty good for my data set. Now, as I told you, I followed the CRISP TM process. Last but not least comes the deployment. So the thing is where I'm going to actually use this model. How is going to be an operational model. So this is going to be used in an HR department. Like before, an employer will, an HR person, the hiring manager will work with the HR person and see if we really want a person for like more than like a long-term employee, because a lot of people can work on their, if they have a US degree, they can work for like couple months with the extension. But if they want to be having like a long time employee, then they want to make sure that the at least LCA will be certified for that employee based on the job title and the wage and his or her background status. Like, is he a willful violator? Is he going to be a full-time employee or part-time employee? And based on that model, we can definitely get our accuracies. Yeah, so that's all for it. And I appreciate you guys for listening. Thank you.